Welcome back to the Michigan Football Analytics Society coding tutorials. Today we will be working on an introduction to Python. So if you want like just the script and not like watching the actual video when I go through each step, you can come to my GitHub and go to NFLR tutorials repository. And then when you go there, there's all the R tutorials that we've worked on that are also on YouTube. So like the introduction to R, the data viz, and like the modeling and stuff like that you can click on. And then if you come all the way down here to tutorial.ipynb, this is the first Python tutorial. So you can go to that script. I would just recommend opening it while going through this tutorial, just in case something doesn't make sense. You can just come over here and copy and paste the line that you need to get into your notebook. So today we'll kind of be going through the same stuff that we went through in the introduction to R with NFL Fast R tutorial, except we're going to be doing it with Python. So Python is a little bit different than R because if we wanted to start on an R project, we would open up our studio and we would open up a script and we would go through that type of stuff. But with Python, we actually want to use this Anaconda Navigator. So if you want to come over to the Anaconda installation documentation, this is how you can get Anaconda Navigator if you don't have it right now. So if you have like a Mac or Windows, then you can click on this. So I'll click on that because I have a Mac. And then you'll want to go through these steps for downloading the Anaconda Navigator. So you'll download it and it'll go through all the steps like this, where you have to click through a couple things and load it into your computer. It does take up a good amount of space, so just make sure you have that when you're downloading it, and then you can install it on a disk and then open up the Anaconda Navigator. So the alternative to Anaconda Navigator is something called Google Colab, which I have had trouble with in the past, but it might work better for other people. And so Google Colab isn't something on your computer. It's something that will be kind of in the cloud, kind of like a Google Doc or a Google Slide is. So when you come to Google Colab, you can just open one of these files. And this is one where I was trying to run R in Google Colab. But it's just a different type of file where you would be able to type Python code like we're about to today. So the first thing we want to do when we start a Python project is we want to come down here to our Anaconda Navigator and open that up. And so it takes a little while to open. And then once this loads, we'll want to open a Jupyter Notebook inside of this. So they have a couple different things you can do. You can even open our studio if you install it through that. But these will already be pre-downloaded for you, these four. So opening a Jupyter Notebook is like the go-to that I've seen for this. And it'll open your terminal and run the command that you need to open a Jupyter Notebook. And then it'll go on to the localhost area here. So I already created a new folder called the tutorials here, called Python tutorials. So I recommend you do the same. And to do that, you come up here, you click on new, and then you click on folder, and it'll make a folder for you. It's usually, yeah, right here. So this one, see, it was made seconds ago. It's called untitled folder. So then you can just go about renaming it to like whatever you want it to be, Python projects or something like that. So so I'll go into my tutorials right here. Oops. And once we have that, we can start on a new project. So just come over here and then click on new again, and then Python 3, which will open up a kernel for the notebook. So inside of this notebook, we can have, we can make a title. So we can call this like first Python notebook or something. or we could give it more of a descriptive name like, NFL first Python tutorial, something like that. So to get NFL data, it's similar to how we did it in our last time we were going about this, where you want to kind of install a package that will do this for you. So inside of these cells, you can kind of run anything. So we can just do like x equals 5, and then we can hit shift and enter, and that'll run it for us. Or you could come up here and you could click like run cell or something like that. And then if we wanted to print something, we can just type X and the output will be 5 on that file or that variable, sorry. And then also, if you want to write something, you can change this cell from a code cell, which would have this in stuff to run it, to a markdown cell where you can type something like NFL tutorial, run that, and then you'll have text on your notebook for when you download it. And so it'll save by going to save as up here and then saving what you need it to save. And then you could also download it at the end. So you can see on the GitHub over here, I downloaded it as a .ipynb. And then, so if you wanted to download this notebook and put it on GitHub as well, you could also download it as a .ipynb, which is a notebook, and then put it on there. So once you have this notebook open, we can kind of take out some of these cells just to clear some space. And the first thing that we want to do to install the NFL package is we're going to run pip install NFL fast py. And so this is just like on R when we do install packages. So I'm going to run this, and what it's going to do is it's going to install all of the packages that we need for NFL fast py, which is the version of Python data from NFL fast R. And so my message might look different than what you get because I've already ran this line before, so it's already been installed for me. And so it might take a minute or two to run that, but eventually you are going to be able to load in the NFL fast py package. Then the next thing that we want to do is we want to import pandas as PD. And so you might also need to upload these files as well. So you could you could also install pandas the same way that we were installing NFL fast py. And so once you have this package, you can import pandas as PD. And so what this does is we could just run import pandas and that'll do the job. But what this as does is it has our pandas package as an abbreviation of being PD, so that when we do stuff with the pandas package, which is like data manipulation and stuff like that, we can just do PD dot instead of like typing out pandas in a full area. Next thing we want to do is import NFL fast py, which we just installed up here as NFL. And then we're going to make a plot at the very end of this. So from matplotlib, import pyplot as plt. So see, we don't want to import all of pyplot. It's basically the way that I've heard it described is you don't want to load up your car with a bunch of camping materials if you're just going to the grocery store, right? So you don't want to over install or over import things that you don't need. So since we don't need all of matplotlib, which is like a graphing package, we just need the pyplot part. So from matplotlib, we can just import the pyplot as PLT. And then another graphing thing, we can import Seaborn as SNS. And then we'll import some other stuff that will help us with the graphing later on, but isn't super important if it doesn't work for you here. So we can run that, and so it'll take a little while to import each package, but it'll load in the data for us. Okay, so once that asterisk goes away, that means that it has ran for us. Did everything load in, Arjun?
I'm still working through some things, but you can keep going.
Okay, cool. Okay, so now that everything has loaded in like that, we can go on to the next step, which is just loading in our play-by-play data to start working with. So here's what this line is going to do. So DF is what we're going to call the data frame. So just an abbreviation for data frame there. And then we're going to set it to the NFL, which is what we loaded in NFL Fast PY as just NFL. And then here's our function, load underscore PVP underscore data. So load play-by-play data. And then in parentheses, the function takes in the argument of what year we want to load in the play-by-play data for. So we want to load it in for 2021. So we can just do it like that. You know, if you wanted to load it in for like a different year, like 2020, you could just type it like that, right? And so now we can kind of see what the data frame looks like now that's loaded in. So the cell stopped running. So we can do df.head. And what .head will do is it'll give us the first five rows of the data frame. If we did .tail, it'll give us the last 5 rows. So we can see this game happened in week 18 of the 2021 season between the Giants and Washington. Or we can go all the way to week 1 of the season when the Titans and Cardinals played, and we can kind of see the different columns there. So some of the things that we can see here is in the pandas data frame, we can see that they kind of number the rows for us. Then we have different play IDs, different game IDs. This is all part of the package that we loaded in, the NFL Fast PY package. And then we can see right here that there's a ton of columns in this data frame. So there becomes a ... And then we can kind of just keep scrolling and take a look and see the different types of columns. So, you know, the expected pass and pass rate over expected and the QB's EPA and stuff like that. And so now we can see what the column names are, since we only can see some of them here. And so on a smaller data set, it can show you all the columns, but we can kind of just see some of them, and we can see that there's 372 columns in this data set. So if we wanted to pick some specific columns, the way to do that is to do 2 brackets and then the quotes of what we want. So let's say we just wanted the post team. So we can do df, then the two brackets on each side. So 2 opening brackets here, quotes post team, 2 closing brackets, and then .head to get the top of it. So we can see it matches up here with this post team column. NAN, the first play was special teams play, home opening kickoff, we can see. And then the first 4 plays of the game were Tennessee. And then if we wanted to look at like additional columns, we can just put commas and quotes in between that. So like let's look at pass and rush, EPA. So we can see this play was the special teams play because 0 pass, 0 rush. This play was a rush play that had a negative 1.399 EPA. And then this play was a pass play that had 0.03 EPA, stuff like that. So now if we wanted to check who the best offenses were based on this EPA column that we were just looking at, we can do that by using the group by function. So we can come df group by, and then what we want to group by is post team. And then the specific column that we want to get within this is EPA. So this could be anything, right? We could do air yards. To get their pass rate, we could do pass, stuff like that. So we can keep the EPA within the double column. So what this is saying is we're going to group by post team. And then within all the variables we could use from that, we're just going to look at EPA. And we're going to want to take the mean of it. So this could be some, if we wanted their total EPA. For now, we can do mean. And then we're going to dot again and kind of chain these all commands all together and say we want to sort by EPA. And then we don't want it to be ascending. So we want ascending to equal false. So that's inside the sort by column. So this is kind of a long command to get it. So just to explain it again, so we're accessing the data frame that has all of our data, grouping by post team, grouping by post team, taking the mean of that. And then once we do that, we're sorting it, and we're sorting it by EPA. The alternative would be to sort it by post team, which it would just list in, well, since we did ascending equals false. So see here, it just lists in alphabetical order. But if we come back and we do ascending equals false, that way we can get the highest EPA at the top. So the Chiefs had the top offense in the league with 0.11 EPA per play, Packers at second, stuff like that. And then we also could get the sum of the total EPA if we wanted to. So we can see that, you know, the Chiefs ran a lot of plays, so they had 164 total EPA. Packers had 128, Tampa 109, etc. Go all the way to the bottom. Panthers had the lowest total EPA, Giants second lowest, stuff like that. So it checks out. And then, you know, if we wanted to go from bottom to top, we can see here, we can just change ascending equals true to, or ascending equals false to ascending equals true, and we can get Giants, or Giants and Panthers with the two lowest EPAs, stuff like that. So this is the final command to kind of get a table on how you know the different offenses performed. Okay, so the next step will be to let's check out how like quarterbacks did last year, and let's look at their EPA and their completion percentage over expected on each play, like their average. So we can call our new data set QBs. We can group by again, and so this is a little bit tricky because there's some, you know, there's some plays where the quarterbacks end up running, so they don't get counted as a passer player, they get counted as a rusher player. So what we can do is we can just use their ID or I guess this is all pass plays. The other reason to use their ID first is because Amari Rodgers joined the Packers, making him A. Rodgers, and so then Aaron Rodgers had to become A. Rodgers to give the difference between the two. So if we just keep it by ID, then that way it won't mix up, it won't take Aaron Rodgers and Amari Rodgers and both make them the same player and stuff like that. So here we can do group by passer player name or passer player ID, comma passer player name. So to do that, we did the parentheses and like kind of like a brackets to show a list. So we're grouping by that. And then we do as index equals false, close the parentheses. And then we're gonna wanna get multiple variables out of this, right? So let me just go into the next line here. So we can open up these parentheses again for aggregate. We just close this parenthesis, and we can say that we're gonna count how many play IDs there are to get how many plays that a quarterback played in, so we don't have small sample sizes. Then for EPA, we're gonna want to get the mean of that, and then for CPOE, we're also gonna get the mean. So this aggregate is like the summarize function in R, if you're used to that. So it's going to do 3 different things for us. It's going to make 3 different columns, new columns for us, other than these passer player ID and name. As we're going to count how many plays they had. We're going to get the mean of their EPA. We're going to get the mean of their CPOE. So we can run that, and then come down here and just print it out and see what happens. So we can see Brady and his, passer player. Lee, I think he's like a punter or something, so that might have been trick play. So that's why we're going to want to filter it out eventually. So how to filter in Python is to use the LOC or loc function inside. So we're gonna want to say QBs to say the data set. We can just put it back right into QBs. Usually you don't want to overwrite data, but it's fine for this one because we could just run this whole cell if we needed to change something. And then we want to say the amount of play IDs we want is greater than 199, let's say. So 200 or more passes. So run that, and then we can see here that we have some different players. Okay. So the next thing that we want to do now is we want to sort this data set on their EPA. So to do that, we can do QBs dot sort values EPA, the ascending equals false that we did up here to make sure it goes top to bottom, and then in place equals true to make sure everything stays together. And then we can see Aaron Rodgers with the highest EPA, Stafford, Mahomes, Brady, Dak, stuff like that. But this table looks a little bit messy. So something we can do is we can use the round function to get rid of that. And so what the round function will do is it'll round each of these to 2 decimals. So that's why we do round equals 2. So we can see now we have 0.31 EPA. We just want to, if we wanted to go more, we could do 3 decimals. We could do 0.306, 6.0681 or 6.068. So, but we'll keep it at 2 for now. And then we can just rename some of the columns just to make it easier, because play ID isn't what this column is supposed to be called. So QBs.columns, by doing this, we're accessing the columns. So there's a list of these 5 columns right now, which I actually can show. So we can see there's a list of these 5 columns right now, right? So what we're going to want to do is we're going to want to do this ID, player, dropbacks, EPA, and CPOE. Now lists are something that are used a lot in like Python courses and stuff. You know, so they're sometimes used in data manipulation too. So they're handy to have. Like if we were to set names list to something, we can run that and we can see the list. And then you know, they're mutable, so we can add something like a dot to the list, and we can see that the list updates like that if we have to. But we'll get to that more of that later. Okay, so now we have this whole function that will give us each quarterback's EPA in ascending order, all the way from Rodgers to Zach Wilson. And then we can see their dropbacks, their CPOE, their ID, their player number. So just to go through this whole cell again, since it was kind of long, the group by is taking the ID and the name, and then we're aggregating it based on the amount of plays, the average EPA and average CPOE. This line right here is filtering to make sure we have dropbacks over 199. Then we want to sort the values, so we want to ascend it, but we want to keep everything in place. We want to round each of the columns, so we do dot round 2, and then we want to change the column names within the list, and then this last line right here prints out the QBs. So after that, we can work on the next step here, which is making a graph. So the data manipulation to get what we want for this graph should be pretty easy. When it goes into the actual graphing part, it gets a little complicated. So just bear with me there, and just remember that if you need to, just come over here and copy some of the stuff that I have on the GitHub if you run into any trouble. So we want to create a new data set with just the passes. So we're going to use that lock function that we used earlier. So we'll use the brackets, and then we'll use we'll use brackets, and we'll use the parentheses inside of the brackets, and then we'll say df, and we'll access pass attempt in there. We'll say equals 1. And then we want this bracket, which is the whole filter statement, to carry on, because we're going to do multiple things here. What we need to do is we need to make sure we're just getting pass attempts. We're just getting air yards that don't have NAs. And then we want to see quarterback aggressiveness on late downs, let's say. So we just want to get 3rd and 4th down. And so the reason I'm doing this is to just show different ways to filter data. You know, I don't know how useful this graph necessarily is, but this is like, you know, a simple way where pass attempt equals 1. Then we need to make sure that you know, there's not NAs on these air yards. So again, we can use the and symbol to string something together, the ampersand, which is the and symbol in Python. Not null is a function that we want to use. So that's like is.na and r. So then we close and then we want to use another and, close those parentheses, use another and, where we say we want to access down when we want to say is in parentheses, and then our brackets of list. We just want 3rd and 4th downs. So now we can see, actually, why don't we, so if we just wanted to print out down and air yards, we can see, okay, good. We only have 3rd and 4th downs. We only have air yards without NAs and stuff like that. So again, just on this, the lock will span the whole brackets, and then inside of each one we have parentheses and an and symbol to string these all together. Another thing you could do is use the or symbol. This wouldn't work in our situation, but that's just like a different way to do this function. So this would do what it would take pass attempts or plays where air yards were not null, or where down is not 3 or 4. So we would get some first and second downs and stuff like that in there, because there would still be pass attempts even if they're not third and fourth down. And we would get some run attempts because they wouldn't be pass attempts and stuff like that. Then we can just select the columns we need here. So we can take their ID, their name, their post team, because we're gonna link that up to their team colors eventually when we make their graph. Their yards to go, and their air yards. We can kind of see what that looks like by printing the data set. And then on top of that, we can see, we can create a new column to do yards past the sticks, because we wanna measure their aggressiveness, right? And so what we can do is we can take air yards and we can subtract it from yards to go. So yards past the sticks is our new column name. So we're putting it in these brackets on DF passes, which is our data set. Oh, sorry, this should be called DF passes. DF passes. And then we're accessing air yards inside of DF passes, and we're accessing yards to go also inside of DF passes, and we're making our new data set, or a new column. Sorry. So this is good now. So we can see Ryan Tannehill on third down threw 10 air yards when he needed 10 yards, and so that's what gets 0 yards past the sticks. And then like here, he had minus 17 yards past the sticks when he threw -1 yards and needed 16 yards. So if we want to look at like the top 10 or the 10 first plays, we can see Kyler Murray. We can see, I guess, Titans backup quarterback or something, and stuff like that. So now let's see who had the highest in this data set. So what we can do is we can create a new data set called top 10 DF passes, and we can group by. And then we can do what we did last time, where we group by both ID and name. And then this time we also want to have their team that they play for in there, because we will we'll get, you know, their team colors and stuff. And so you know, we can see over here that we're going to want to take their yards past the sticks. Oops. And we're going to want to summarize it and then sort the values by equals yards past sticks. And so yes, this becomes a long function, so you can kind of just hit enter and put the second part of its own new line, so we can kind of see what this looks like. So this isn't the top 10 yet. You know, this has all of the like every single player that we need right now. So we can kind of see, you know, just the total yards past the sticks. Oh, I guess we could do ascending equals false here. And so we can see Stafford has the highest yards past the sticks on late downs. Russell Wilson has the second highest, Dak, Cousins, Herbert, stuff like that. And then, sorry, 1 second, need to go into here, remind myself how to get the top 10 again. Oh yeah. Okay. Okay, so now we can see this has 92 rows right now. So like every player that had like a third and fourth down play. So to just get the top 10, we can do this colon, and then we can get 10. If we just wanted players like 2 to 10, we can see here that we took out Stafford, right? Because we put 2 to 10. If we just want 1 to 10, oh sorry, on 2 to 10 we took out Stafford and Wilson. 1 to 10 we take out just Stafford, and that's because Python is a zero index language. So what that means is the first row is 0, and then the second row is 1, and third row is 2, and stuff like that. So that's why if we did like 9 to 10, it would just be the 10th player, and you can even see right here he's listed as the 0th player because he's the first. So dash 10 just means we get everything before then, or we could just do 10 down, which would take the 11th player and go all the way down to the last one. So we can see there's 82 rows right now and stuff. So that's just the different ways to play around with the ordering of all of this. And so now what we're going to want to do is we have their post team here for a reason. That's because in this graph, we want to show their team colors. So we can load in their team logo colors data set from the NFL package that we did. So that's NFL.load underscore team underscore logo underscore data. And so now we're going to need to merge these two data sets together. Actually, before we do that, we're going to we're going to want to show their distribution of the yards past the sticks on these late downs in the graph. But we in our DF passes data set up here, we just want to keep these names that were in the top 10 here. So so we're just going to want to say we're going to want to filter. So we're going to want to use that loc function that we've been using a lot. And we're going to want to say passer player ID dot is in the top 10 passer player ID. So this might be a little confusing, but basically what we're doing is we're taking our DF passes data set from up here with all these guys, Tannehill, Murray, Farley, all these guys. And we're saying, okay, we just want the IDs that are in these top 10 to stay in the data set. So we can see when we run this, this is what DF passes the first 10 rows look like before. And then now this is what it looks like. See, Tannehill got filtered out because he wasn't in the top 10 for this metric that we made up. So we can see it was just Kyler Murray in that first game. Now we have Derek Carr coming in now here. It took out Farley and all that type of stuff. So sorry for doing this kind of backwards. If you wanted to write like sequential programming, filter it first, and then we can worry about the team logos later and stuff. So then we can load in the team logos now. But I forgot about that stuff there. So that's my fault. So now we can merge the team logo colors. And so we can select just what columns we want from the team logo color. So if anyone remembers from the R tutorials, this is the same data set when it's called team logos colors. And it has a bunch of things, right? It has like their nickname and their full team name and their image and stuff like that. We just want their team abbreviation to merge the data set. We just want their team color, and we just want their second team color. And then we want to rename some of these. So gotta look back at what I renamed it initially. So columns equals, okay. Yeah, so what we want to do here is we can see that this is you know, the player's team right now is post team, but um, you know, in the team logos colors, it's team abbreviation. We want to match those two columns up. So that's why we're going to say columns equals team abbreviation post team. And then we're going to want to say on equals post team. So again, this becomes kind of a long command. And kind of do that, I guess, to make it look easier. And so now we can, again, print our DF passes, and we can see, okay, so it has the team colors. Oh, wait, why does that look weird? Let's see what the difference is here. Oh, okay. Okay, there we go. Okay, what had happened was I must have accidentally ran that line twice, so then it was duplicating these two column names. So if that ever happens, just, you know, go back up to the previous cell that we were just working on and just rerun that, and then come down here again and do that. Okay, so now we can create the plot here, and then that will be the last thing that we do in this tutorial. So again, like I mentioned, the code for this plot is kind of deep in the weeds, and you shouldn't expect to know anything. I borrowed it from Fantasy Pros, I think was the website. I'll link it in the description on the YouTube video. But I borrowed parts of it and modified it to fit what we were working on. So we have 10 quarterbacks in this data set. And so we can, you know, we can do, let's do like 5 rows and 2 columns. So we're going to want to create subplots for each quarterback, basically. So 5 rows, 2 columns. That's what the 5.2 is. And then we want the figure size to just be 10 by 15, let's say. That should give us enough room. So when we run that, we can see, okay, these are all blank right now, but we have the 5 rows, 2 columns, and we can see it's 10 wide and 15 vertical. Then we're going to want to use the lambda function, which will be explained in. So what the lambda function is going to do is we're going to make this function called t, basically. Or we're gonna make this function called flatten that takes in an input t, and we're gonna kind of create this item for sublist and t, for item in sublist and t, so, or in sublist. So this, it's a little complicated, but we'll see once it all bears out. So we want to get the axes. We're going to want to flatten our list of axis lists. And then we're going to want to get our player labels. So how we can do that is we can use our brackets. So we can get the first group, or the first thing from each group. So that's why the -1 comes in. So just to show, if you have a list, names list equals Wilson, Brady, Herbert. Let's say you have a names list and you just want to get the first thing from the list. You can do, or sorry, the last thing from the list. You can do names -1, and it'll get the last thing from the list there. So I'll print out Herbert. So this one here, we're going to get the last name in the column to get basically their most recent name if they had a name change or something. And we can get their ID there. Okay, so now is the kind of long piece of code that will zip all of what we just did and the axes all together to make our graph. So we can say zip axes and players. And then this is the SNS, which is the seaborn that we loaded in all the way back here, import seaborn's SNS, that's used for graphing. So SNS dot KD plot the player data frame that we have. We're going to want to access the yards past sticks in them. X equals X. So these are just different, functions. We're going to want to give it a color. So we're going to want to say team. We're going to want to say their team color. And then like the first one of it. So dot values there. And so now this is to fill in the area underneath the curve. So we're going to want to do that. And then we can say dot get XY data. And then within that XY, we can access it, get the first one and second one. And then we're going to want to fill between on that. And get the color, the team color. Okay, so now we can adjust the Y ticks to only include certain values, because right now it goes from 0 to 1. This is like a density plot, so someone's not going to have like a density of 1 at a certain yards past the sticks or whatever. So like that would mean they're only throwing at that yards past the stick. So at the highest, to be safe, it'd probably be 0.2. If anyone goes off the the thing, we can check for that. And so then we can do pass their player name equals the player data frame. Pass their player name, we can access that. We can get the first one again. And then we can do access that title. We can set this way, it'll give the a different player name for each one, and then give it a font size of 16, font weight of 450. And these are just attributes that I had, so you can feel free to mess around with those. And then we want to set a Y limit and X limit like we did here. So we're seeing it's going to go from 0 to 0.2. So bottom equals 0, top equals 0.2. And then we can also set an X limit. Actually, let's do -10 here. Okay, so let's see what we got so far before we go to our next step. So we can see it shows up a little bit weird because we haven't adjusted all this name stuff here. We can see this is a pretty good curve. And if anything, we can start to play around with these. So why don't we do 15 to 40? And then we can set the ticks at 0.05 and 0.1 because we can see that, none of them have a density that's going even close to 0.1. So this should be a safe bet to do that. So let's run that again and see that looks better. So now we can see we have ticks at around 0.05 and 1.0. we can kind of see their each curve. It's like Kyler's is flatter than the rest. Herbert's is more concentrated at 0 kind of. Brady's and Stafford's look pretty identical. Russell Wilson has a slight bump in the 20-30 range, so that's pretty cool stuff. Let's give our plot a title. So fig dot subtitle. And then we have to put this one in quotes because we're going to do top 10 QBs and apostrophes. If we did this in apostrophe, then it would get confused. It would think this apostrophe was with that apostrophe. So keep that in mind. I usually just do quotes unless there's going to be an actual quote in there. So top 10 QBs and yards past sticks in 2021. And then give that a font size of 18. And then let's give some margin in between the different one. So fig dot tight layout. So now this is looking a lot better. We can see, it's getting there. Okay, and then the last thing that we want to do is we can kind of just adjust and make some room for the super title at the top. So subplots, adjust. And then let's make sure the background color is white. Oh. Oh, sorry. Fig dot set base color. Oh, sorry, it's subplots. Losing my concentration at the end. There we go. So now this is the plot that looks pretty nice, I think. And there's a lot of stuff we can kind of do differently with it. So if we wanted to do like three rows and 3 columns, we can come up here and we can say 3 by 3. We can change that to top 9 QBs. See what it looks like. So now we can see, different density curves for the top 9 quarterbacks. So that type of stuff. And when you're done, go up here. You want to share this on Twitter or something, you can save it. So, save it, or you could just copy the image, stuff like that. So this graphing part was a little bit complicated, and the next tutorial we'll do some different types of graphs where we plot team logos and stuff like that. But this was the initial introduction to working with NFL data in Python. So we did a lot of stuff here. If you want to download this notebook and make it look clean, you can restart and clear output, and that will so that'll just put all the code just like this. Just a reminder that this will all be uploaded on GitHub, just like that. So and with comments and everything. So again, just at my GitHub, Seth, TEJSETH/NFLR tutorials, and then it'll be tutorial1.ipmy, and then here's all the R tutorials that I've done on the MFans YouTube account. And so feel free to reach out to me on Twitter if you have any questions. I've had a lot of people reach out and say that they've done the tutorials and they've run into an issue, and I've been able to look at it and usually solve it. But I'll try my best. I can't promise for sure, but yeah, thanks again for the feedback and everything. And we'll be back in 2 weeks with some more graphing